In section 5.3, we're going to talk about two different special triangles that we'll see. And you should have these memorized, and we're going to see them over and over and over again throughout this entire semester. One of which is the 30, 60, 90 triangle. Now, it's called a 30, 60, 90 triangle. The 90 degrees means we've got a right angle, which we do, that's that little box. And then we've got a 30-degree angle and a 60-degree angle because, remember, all the angles in a triangle always have to add up to 180 degrees. Now, another thing is our longest or biggest angle should match up with the longest side of our triangle. We'll notice that the longest side of our triangle is side 2, so it should be opposite of the largest angle, which is the 90-degree angle. So the 90-degree angle matches up with the largest side, which is the side that has a value of 2, opposite of it. The next biggest angle is a 60-degree angle, which should have the second biggest side, which is the square root of 3, which is approximately 1 point something. So it's the second biggest side, and it's the second biggest angle. That makes sense. So the 30, 60, 90 triangle has a side of 2, a side of the square root of 3, which is the second biggest side, and the second biggest angle, which is the 60 degrees. And the last angle that we care about is the smallest one, which is the 30 degrees has the smallest side, which is side value of 1. So the 30 degrees has a side of 1 opposite to it. Now let's look at the second most common triangle that we'll see, which is the 45, 45, 90 triangle. Again, notice that it has a 90-degree angle. It's a right triangle. So its longest side will be opposite the 90-degree angle, which is the longest side, the hypotenuse, which is going to be the largest side is square root of 2, which is again going to be about 1 point something. Now, it doesn't hurt to become familiar with the actual decimal values of the two square roots we'll see the most. The two square roots we'll see the most are the square root of 3 and the square root of 2. The square root of 3 is 1 point, and we'll go ahead and fill this, 7.7 something. And let's see, the square root of 2 is about 1.4 something. Just to give you an idea. And then we have actually two more angles, but at least they're the same in this one. The two other angles we'll see are the 45 degrees. Because they have the same degree, they should be the same. The sides that are opposite should be the same, which are both size 1. So because the angles are the same, their opposite sides should be the same. So the 45-degree angles both have a side of 1, and the 90-degree angle is the one with the confusing one, has a side of square root of 2. So the 30, 60, 90 has the square root of 3 in it, and a 1 and a 2 as its sides. The 45, 45, 90 has two sides that are length 1 and one side that's square root of 2. Now, the reason why we want to have this memorized is so that we can come up with the 6 trigonometric values for these right triangles, these two special right triangles. So let's take a look. Let's take a look at problem A. Let's start by drawing out our right triangle. Notice they mentioned 45 degrees as the angle we want to look at, so that automatically tells us that we're going to be looking at the 45, 45, 90 triangle. So I've already drawn in the 90. It means the two other angles have to be 45 degrees if I want a 45-degree angle. And again, how we know that we're using a right triangle is because they're mentioning that we want to find the 6 trigonometric functions. Remember, when we talk about the 6 trigonometric functions, we are using a right triangle. So the key is going to be remembering that the longest side, the side that's opposite the 90-degree angle, and a 45, 45, 90 is a side of 2. Then the other two sides have to be the same, opposite the two 45-degree angles, and those are both of side 1. And I said the hypotenuse should be 2. I meant square root of 2, excuse me. So our 45, 45, 90, opposite the biggest angle, 90 degrees is the longest side, which is square root of 2. And the two 45-degree angles, because they're the same, should have the same sides, which are both just a regular value of 1. So now what we can start doing is then find the sine, cosine, tangent, cosecant, secant, and cotangent. So we'd start out with sine of 45 degrees first. Then we continue along by finding cosine and tangent of 45 degrees. Then we'll find the cosecant, secant, and cotangent of 45 degrees. But let's start out with sine. Remember, sine is the SOHCAHTOA, and which means we're going to be looking for opposite over hypotenuse. Well, let's take a look. We're going to be starting with the 45-degree angle, and it doesn't matter which of the two 45s because they have the same angles and the same values for their sides. So opposite over hypotenuse, though, opposite would be the side opposite of the 45-degree angle, which is 1, over the hypotenuse, which is our longest side, which is opposite the 90-degree angle, which is square root of 2. There is a problem with this. This tells us that sine of 45 degrees is 1 over the square root of 2. That is not okay. Remember, we cannot leave a square root on the denominator, which means I'm going to need to multiply the top and the bottom by a square root of 2 to get the square root out of the denominator, which will then give us on top, when we multiply 1 times the square root of 2, it gets us the square root of 2 over square root of 2 times square root of 2 in the denominator. We'll have the square roots cancel out, leaving you still with a 2, though. So that tells us that sine of 45 degrees is square root of 2 over 2. Then you would move along to finding cosine. So I can go ahead and fill that in on my table, that sine of 45 is square root of 2 over 2. So here we go. Sine of 45 is square root of 2 over 2. Next, let's work on cosine of 45 degrees. Well, that would be our ka and SOHCAHTOA. Well, that would be that our cosine of 45 degrees is going to start out with our adjacent side. Well, our adjacent side to our 45 degrees is also a value of 1. Over the hypotenuse, which we already said is the longest side, which is that square root of 2. So we'd start out with the same problem once again, that you can't leave a square root on the denominator. So you'd start off the same way by multiplying the top and the bottom by a square root of 2, which would give us, let's see, square root of 2 over 2. Because again, we'd have 1 times the square root of 2 on the top, which gives you the square root of 2, and square root of 2 times square root of 2 does just leave you with 2 on the bottom. So square root of 2 over 2 would be the same answer for cosine. Then lastly, we would start with tangent of 45 degrees, which is our TOA, which is opposite over adjacent. Well, we already talked about the opposite side of the 45-degree angle being 1. That would be your first side for opposite. Then your adjacent side, it's the side right next to your angle, which would be also a 1. So that would get us for tangent 1 divided by 1, which is 1. So we go ahead and fill that in for our tangent of 45 degrees is just 1. Then we can go on to our cosecant, secant, and cotangent, which are all going to be reciprocals of the other 3 trig functions we have already found. The easiest is taking tangent and finding cotangent. Remember, cotangent is just tangent's reciprocal, so it'd be just taking the 1, which was 1 over 1, and flipping that upside down. Well, if you flip 1 over 1 upside down, you still get 1 over 1, which is 1. So both tangent and cotangent are both going to be 1. However, let's talk about secant. Secant is the reciprocal of cosine, which would mean taking the 1 over the square root of 2 would be the easiest way to look at it, and flipping it upside down. Well, if you take the 1 over the square root of 2 and flip that upside down to get its reciprocal, you'll get the square root of 2 over 1, which is just square root of 2. So that gives us that secant is just a regular square root of 2. Notice it's okay because when you flip it upside down, the square root of 2 does land on top. Now let's take a look at sine. Same idea with sine. I'd flip it as it originally was, the 1 over the square root of 2. So when you flip that upside down, it will become square root of 2 over 1, just like with secant. Well, square root of 2 divided by 1 is just the square root of 2, which means that secant is just the square root of 2. And again, that's okay because the square root is on the top, not on the bottom. So these are your 6 trigonometric values for a 45-degree angle or a 45, 45, 90 right triangle. And we'll use these over and over and over again in this course, this specific set of sine, cosecant, cosine, secant, tangent, and cotangent. But I would really only worry about how to find sine, cosine, and tangent. Why? Because we know that cosecant, secant, and cotangent are just reciprocals of the other 3. Now let's